to Maths with Bob. Today we're looking at basically the first in a series of integration by substitutions. We're looking at definite integrals. Obviously they've got bounds. And the first idea is what's going on when I do a substitution? Well, I always say we're going to a different plane. We do normally what's called a U substitution. This is the beginnings of all sorts of transforms. We can get into integral transforms and multiplying by integrating factors and all sorts of things. But basically, the idea is to change your integral from something you can't do to a standard integral, which you can do. Okay, so I guess that's the overriding idea. Okay, so first up, let's have a look. What are we going to do? Well, let's have a look. What is our substitution going to be if we're not told? Well, I always go to the brackets. Whatever's in the brackets, try let u equal 5x squared minus 1. Okay. And then we just differentiate this. We get what? du dx. Okay, it's just 10x. It's not too bad. Then multiply both sides by dx and get du equals 10x dx. Okay, divide by 10 and I'll get 1/10 of du equals x dx. Now you can see here, okay, the derivative of what's in that brackets is in fact 10x. We have our x dx. If you have a quick look, we can see here we have an x dx in our integrand, and we're going to replace that with 1/10 of du. And we're going to put the 1/10 outside the integral sign. We can move the constants through the integral sign if you like. Okay, now there's something else which we need to do as well, which is change the bounds. Okay, so we are going to now change the bounds. Okay, because at the moment we have what's called x bounds, and if you can have a quick look there, you can see. Okay, it's integrating with respect to dx. Okay, x is 2 here, and x is 0 here. Okay, so they're called x bounds. When we do a substitution or change a variable, if you like, we need to change them to whatever variable, in this case u, we need to change them to u bounds. Okay, so we just say, okay, let's have a look. If x is equal to 2, what's u? Well, u, we just substitute it into the substitution, okay, which is 5 lots of 2 squared minus 1. What's that? 5 fours are 20 minus 1, which is 19. So our u bound of 2 corresponds, our x bound of 2 corresponds to a u bound of 19. How about if x is equal to 0? If x is equal to 0, u is equal to, what's that, 5 times, most of us can see it's actually going to be -1, okay? Okay, so basically the x bound of 0 corresponds to a u bound of -1. So let's actually do the transformation. Okay, so let's actually transform the integral. Okay, here we go. Now we've got to make sure we don't have any x's left. I've actually sometimes seen people half do a transformation. Okay, you can't leave x's. It all has to be in terms of u's now. Okay, when I do a u substitution or variable change, it needs to be changed to the new variable. Right, so let's have a quick look. X is 0 was -1, so we go from -1 up to now it's 19. Okay, the x dx was in fact, as we said, was 1/10 of du, and I was going to put a 10th on the outside, 1/10 du. Now, you can see here that the 5x squared minus 1 was u, so that's actually u to the power 4. Okay, so let's actually do this integration. I'll just rub our working out here. Okay, so we've now transformed our integral into an integral which we can do, so that was our idea. So we're now going to do our integral. Okay, so it becomes what? 1/10 integral from -1 to 19 of u to the power 4 du. So obviously that's just 1/10. We're going to go u to the power 5 over 5. We're going from a 19 up the top there and to -1, or from -1 to 19. So do this integral now. We're substituting the 19, so it becomes 1/10 of, now it becomes 19 to the power 5 on 5, minus, now it's -1 to the power 5 on 5, and you can see here that would be a negative 1. So we'd add that 1/5 to the 19 to the power 5 on 5 and divide by 10. So it works out to be about 49,522 when you divide by 10. So 49,522. Okay. All right. Okay. So you can see here we transformed the integral into something which is a very easy one to do. Okay. All right. Let's go on to example 2. Okay, let's have a look at our second example. Here we go. Integrate from 1 to 2 of 7x dx all over the square root of x squared plus 1. Now, there's no brackets there, but there we can see here a square root sign, so we normally could write that as to the power of half on the bottom there. So we'd always go and say, okay, the first try would be, okay, let u, the variable, be x squared plus 1. Then I just differentiate again. Du dx with respect to x is 2x, and I just get du is equal to 2x dx after a while. You can see here, okay, that x dx is actually just a half of du. Okay, we've got a 7x dx there, but we'll fix that up in a minute. Okay, so let's actually then look at, okay, what are our bounds going to be changed to? Okay, so remember these are x bounds, so yeah, if I say x is equal to 2, the top bound there, u is equal to 2 squared plus 1 from our substitution. Substitution, okay, we're using is this one here, okay. Okay, u equals x squared plus 1. So we just square the x and add 1, and that becomes the u value, which you can see here would be equal to 5. Okay, so I'll just, okay, so this would be equal to 5. Okay. So when x is equal to 2, u is equal to 5. Now, the other one is 1. X equals 1. U is equal to 1 squared. Okay, just substituting it back into this u variable equals x squared plus 1, and you end up getting 1 squared, okay, plus 1, which is 2. So the x variable of 1 corresponds to a u variable of 2. Okay, so let's actually transform this integral to start with, and then we might need to rub out this to form a bit more space. So first of all, let's transform the integral back into, change all the variables to u. Now, you've got to make sure you don't leave x's around. It all has to be in terms of u now. So we need the u bounds to start with. The u bounds are going from, okay, from 2 to 5. 2 to 5. Now, the 7x dx, well, we haven't got a 7x dx. We only have our x dx, which is a half. So that would form 7 on 2. But I'm going to take the 7 on 2 outside. So I'm going to get 7 on 2, okay, I'll get a du, and then I'll get a, what you can see here on the bottom, a u to the power of half, which we'd rewrite as u to the power negative a half, and then we'd integrate it. So let's go ahead and, okay, I'll first of all rub some of these things out. Okay, so we now have our integral transformed. Okay, so let's actually keep going. Well, let's see, okay, all right, so let's actually do this integral now. So we have 7 on 2, the integral from 2 to 5. We have u to the minus a half, okay, du, okay. So we're going to have to add 1 to the power and put it over the new power. So we're going to get, what are we going to get? Well, we're going to get 7 on 2. Now, u to the negative 1, well, negative a half plus 1, I should say, brings it up to a half. I'm going to divide it by a half. So I'm going to multiply it by 2. I'll just fix that up here. And then I'm going to obviously need to put my bounds in between, you can see here, 5 and 2. So I'll fix up the constant at the front. Okay, let's fix up the constant. It's going to be 7. Okay, so we're now going to, let's reform this. Okay, so it's going to be what? 7 lots of u to the half, going from 5 to 2, which you can see here, 7 lots of, okay, u to the half, which is 5 to the half, or the square root of 5, minus, put in 2, square root of 2, okay, and we're going to need to do this on the calculator, but I think it's about 5.75 to correct to 2 decimal places. So it's about, okay, 5.75, okay, it's 5.75, okay, 75, that'll be square units under this, there'll be an area idea, but this is 2dp. This is correct to 2 decimal places. Okay, Here's example 3, the integral from 1 to 2 of 4x plus 6 all over x squared plus 3x minus 5 cubed in the denominator there, dx. Now the first thing I usually do is I move the dx. I'll just show you what I normally do is I put the dx up here in the numerator, dx here, and okay, I'll just put this one down here. Okay, so you can see here the derivative of x squared plus 3x minus 5 is just x squared plus 3, which is double the 4x plus 6. Now, if it wasn't, we have to do a lot more work on this integral. But most of these are basic substitutions, and they're going to be working nicely for us at this stage. Okay, so the first thing is, let's have a quick look. What are we going to do? Well, let's do our u substitutions. Okay, let's let u now go to the brackets. So it's going to be what? X squared plus 3x minus 5. Now, if you like, du dx, okay, is just 2x plus 3. And if you like, du is equal to 2x plus 3 times dx. Okay. And you can see here we've got a double that on the top there. Okay. So let's actually now change the bounds. Okay, we remember have x bounds, so we're going to change them now to u bounds. Okay, so if x is equal to, say, 2, the top bound there, u would equal what? Okay, so it's going to be 2 squared plus 3 times 2 minus 5. What's that? 6 and 4 is 10 minus 5, which is just 5. Okay, so our x bound of 2 corresponds to a u bound of 5. Okay, if x is equal to 1, let's have a look. U is equal to what? 1 squared plus 3 times 1 minus 5. So that's negative 1. Okay, negative 1. Okay. Okay, so we now are going to change our bounds. So let's just change our bounds, just change the integral, or if you like, transform the integral. And hopefully we'll be able to do this one. Okay, so let's have a look. The transformation would go like this. Okay, we've got 4x plus 6 dx, so we've actually got 2 du on the top. We've got u cubed on the bottom. Our bounds were now going from minus 1 up to 5. Okay, so we now have the integral transformed into an integral we can do. So let's actually have a go at it. Okay, let's rub out that working. Okay, and have a look at. Okay, so the first thing we do is probably take a 2 out. We rewrite the u cubed on the bottom as u to the minus 3 du. Okay, the bounds are still there, minus 1 and 5. Okay, then we can quite easily do this integral, okay, which is 2. Now this becomes what? U to the minus 2, we have to add 1, so it's u to the minus 3. If you like, add 1 minus 2 over minus 2. Okay, it's from minus 1 to 5. You can see here we actually can cancel. Let's actually cancel the 2's here. Got a minus 1 still left on the bottom. Okay, now let's actually work this out. Okay, this would be equal to, now what? Just write it as u to the minus 2 is 1 on u squared. Okay, there's actually a negative sign there as well, going from 5 to negative 1. Okay, so let's put in 5. We'll put in minus 1 on 25 and put in minus 1. It becomes minus 1 on minus 1 squared. Okay, now there's also going to be a little bit careful here. There was actually a negative here as well. Okay, so sometimes it's got to watch the signs. Okay, so that turns out to be a positive one. So minus. Okay, so we end up getting. What do we end up getting? What? 1 minus 1 on 25, which is equal to 24 on 25. Okay. All right. Let's go on to example 4. Okay, here we have example 4, and you can see this is a bit different. I can't actually let u equal x in this case because it'll just be the same integral. Okay, so I have to be a little bit sneaky. I have to actually do what's called a rationalizing substitution. So I'm going to let u now equal the square root of x. Okay, and some people say, okay, well that means that u squared is equal to x. Therefore, you can say, okay, if I differentiate everything with respect to x using the chain rule, I'll get 2u du dx is equal to 1. Therefore, if you like, 2u du is equal to, okay, dx. Okay. All right, so we now know that dx is actually 2u du. Let's actually have a quick look. What about the bounds? Okay, the bounds. Okay, if remember these are x bounds. If x is equal to 4, we know that u is equal to, okay, the square root of 4, actually, just 2. If x is equal to 1, you can see here u is equal to the square root of 1, which is just 1. So our x bounds from 1 to 4 now change to 1 to 2. Okay, instead of going 1 to 4, we go 1 to 2. Right, okay. So let's actually convert, see what happens. Okay, so we end up getting, okay, we have a 2u du in the numerator. We have a 1 plus u in the denominator. Our bounds now go from 1 up to 2 instead of 1 to 4. Okay, so how are we going to do this? Okay, let's have a look. First of all, let's rub out everything. Okay, now the integrals are starting to get a little bit more complicated now. You can see here I need to break this up with partial fractions, if you like, or try and break this into separate fractional parts. And the way we do that would normally be, okay, I'll show you quickly. We go u plus 1 into 2u. That goes what? 2 times? 2 times u plus 1 is 2u plus 2, and we subtract, we get a minus 2. So basically 2u on 1 plus u would be written as 2 minus 2 over 1 plus u. Okay, 1 plus u. Okay, so we're going to break that fraction up into its parts, if you like. Okay, so let's have a look. Okay. Okay, so let's do it. So we now have what? The integral from 1 to 2. Now it's 2, you might remember, 2 minus 2 over 1 plus u du. Now we can actually do this quite easily because we know that's a log integral, and we can see here that this would be just equal to what? 2u minus 2 ln 1 plus u. We need to evaluate this between, you can see here, 2 and 1. So let's put it in. What's that? 4 minus 2 ln 3. Then, okay, minus, okay, 2 minus 2 ln 3. Okay, and let's try that. What do we get here? 2 minus, so it's going to be what? Minus 2 ln of, now that becomes a positive, so that would be, the 3 would be on the top. Okay, all right. Okay, well, let's look at the final example in our series. And again, here this is a bit of a tricky one. You can't let u equal x, okay, or x plus 4 even for that matter. And what we're going to do is we're going to do another rationalizing substitution. We're actually going to let u equal the square root. Okay, we're going to let u equal the square root of x plus 4. Okay. Or, if you like, u squared equals x plus 4. Now, okay, now you can see here there's actually an x on the bottom, so this is quite a good way of doing it. So square both sides, okay, then you say differentiate the whole expression with respect to x, you'll get 2u du dx using the chain rule equals derivative of x plus 4, which is just 1, and you end up getting again 2u du equals dx. Okay, dx, what am I saying? Dx. Okay, so basically we'll need to replace the dx with the 2u du. Okay, so what are the bounds? Okay, let's just check the bounds out too while we're here. We need to change the bounds. Remember, these are x bounds. We need to change them to u bounds. So if x is equal to, say, 12, okay, u is equal to the square root of 12 plus 4, obviously, square root of 16, which is just 4. Okay. How about if x is equal to 5? Okay, u is equal to, you can see the square root of 5 plus 4. Okay, 3. All right, so our x bounds, 12 and 5, have changed to 4 and 3. Okay, now, a couple of things. Okay, we can see that x, the square root of x plus 4 is actually u, but what is the x? Well, this is where we sometimes need to rearrange our substitution. So if you have a quick look over here, what is x? Well, x is really equal to what? U squared minus 4. Okay, so we're going to need this expression here, u squared minus 4. So let's actually convert this integral, or transform this integral, okay, if you like, or change its variable. Okay, so here we go. The integral now goes from 5, which was actually 3, up to 4. The dx was actually 2u du. Okay, the x was actually u squared minus 4. Okay, and there was a square root of x plus 4, which was just u. Okay, so the first thing we'd probably do, I think, is the easiest way is to cancel the u's. Okay, have a u here and a u here, and then we actually end up with this integral, okay, which would be 2 over u squared minus 4. Now, we're going to have to do a little bit of a work on this integral, so let's rub this out. Okay, how are we going to do this? Okay. Well, first up, we're going to have to look at how we break this up. Okay, so we're going to have 3 on 4. This leads us to something called partial fractions. Okay, now u squared minus 4 is actually u plus 2 times u minus 2. Okay, now, how are we going to do this? Well, first up, let's have a look. What do we want? We want 2 on u plus 2 times u minus 2. We really want that as, okay, a, if you like, over u plus 2 plus a b, okay, a b over u minus 2. Okay, so what we do is a fairly simple idea. Just multiply everything by the u plus 2 times the u minus 2. You'll end up getting that 2 is equal to like a lots of u minus 2 and plus b lots of u plus 2. Okay, now, okay, these are equivalent, if you like, these expressions, so I can actually select any value of u I like. So let's actually, this is a fantastic idea. If you go, let u equal 2, and that drops out the a, okay, because 2 minus 2 is 0, and gives us, what, 4b equals 2. Therefore, okay, b is a half. So that function here, that one there, is a half. Okay, let's let u equal another nice value, minus 2. I mean, okay, this will give us, wipe the b out, obviously, because minus 2 plus 2 is 0 times b is 0. We end up getting that, what, minus 4a is now equal to 2, and therefore a is equal to minus a half. Now, okay, this is the idea of what's called partial fractions, so this value here is now minus a half. Okay, so we now need to put all this together. Okay, so I'll now just rub this out and we'll put this together. Okay. Okay, you can see I've just put this together. Now, obviously we take the half out, so we just take a half out. The integral of 3 to 4. Now I'd write this as 1 on u minus 2 minus 1 on u plus 2. Now hopefully we recognize these integrals as logs. Okay, so we know that this is really, okay, a half. Now it becomes what? When we actually integrate it, it becomes ln u minus 2 minus the ln of u plus 2. So it's really the ln of u minus 2, okay, over ln of u plus 2. Now we need to evaluate that between 4 and 3. Okay, so we need to plug those values in. Okay, so that becomes what? A half. Let's have a quick look. ln 4, you get okay, 2 over 6, so it's ln 1/3 minus, now you put in the 3, ln 1/5. Okay, 1/5. Okay, now again we're dividing, well, subtracting, therefore we're dividing the log, so it's basically what? 1/2 of what? ln 5/3. Okay, that was a more complicated example, but involving partial fractions. Okay, well, thank you very much for watching. We'll do some more later. Bye for now.